Okay, so we write this as an integral. Huh? Oh, so when I integrate this, an exponential integrates how?
There's logs.
Yeah. As itself divided by what? ln of the base 2. But because of that negative x, I must also include a negative on the boundaries. 1 to infinity. Yes? We okay with our integral?
Yes.
All right, so then we go and plug it in. Now, I would still like that 2 to the negative x to be on the bottom because that's going to help me when I plug stuff in. So I'm going to write it when I do my f of b minus f of a as negative 1 over 2 to the infinity times the ln of 2. Minus a negative turns into a plus 1 over 2 to the first times the ln of 2. Now, this is going to be what? Infinity, which makes this entire fraction equal 0. Plus this. So what does the integral test tell us?
It's a constant, so
Because that's a constant, what do we know? It converges. Yes? All right. Now, by that common sense idea, we would know this converges because this is going to increase huge on the bottom and nothing on the top. So if it's a multiple choice, you do no work and you say by the common sense we know it converges. If you have to like show a test, then we're going to have to actually show your work. All right? All right, my friends. Question 9. What's the issue with question 9?
it's a series, but it's not in a series format.
All right, so some of this is going to be practicing. Too much talking. Shh. Some of this is going to be practicing setting up. Hello?
Hey,
That was aggressive. So part of this unit is writing these kind of things as like a summation. You have to kind of think through how that would work. Typically when we write these, we have to write our summation. We know it always goes up to infinity. N typically starts at what? 1. Yes? So if n starts at 1, but the first term is ln of 2 over 2, how do I have to write it in general notation? ln of what? N plus 1 over n plus 1. You could sometimes start these at 2. Some of the tests only work for particular n values. Like the geometric one, we saw it started at n equals 0. And the integral test actually specifically, if you look in the summary page, starts at n equals 1. So we've got to look at it from that. So from this, we can then go to the integral test. Okay. What are we u substituting? ln of what?
I put L in.
Yeah.
And started with 2.
Okay. So you did ln of n with n starting at 2. I did not even show my u substitution, I don't think. I think I just did u prime with u or something like that. So if I do ln of n plus 1, that means my du is 1 over n plus 1 dn. So n plus 1 du equals dn. So then I can go ahead and make this my u substitution where this is my u over, I'm going to switch these out for x's. I should have done that before u substituting. X plus 1 du. So then that cancels. From here, I'm just integrating u, which means this integrates as 1/2 u squared from 1 to infinity. So then I go f of b minus f of a, which when you plug in infinity to start with means this is going to end up being what?
Mega infinity.
Yeah, mega infinity, right? So what does that mean? Diverges.
Don't you also have to just notice that, like, the top is always getting bigger, so it's never gonna go to, like...
Yes, these are kind of hard to tell because ln is, it's increasing but not that fast of a speed. And the bottom is also not increasing at that fast of a speed, so it's kind of a hard one to eyeball. But 17, integral test on that one. What's our u? Arctangent. Okay, so if I make my u arctangent, I'm going to go to x's this time to make sure I've got that, because this is going to be the integral from 1 to infinity of arctangent x over x squared plus 1, right? Dx. My du, what is the derivative of arctangent? 1 over x squared plus 1 dx. So then x squared plus 1 du is equal to my dx. So this becomes the integral from 1 to infinity of u over x squared plus 1 times x squared plus 1 du. Therefore, what cancels for us? X squared plus 1. So this integrates as 1/2 u squared on the integral 1 to infinity interval. Therefore, this is also going to work out to infinity, which means it diverges. Okay. We ready to go to page 2? Oh, I am not actually sure about that. Sorry, I went way too fast on that. No, I didn't actually do u boundaries on that one. Look at me. All right, go back. If I was to do u boundaries here, okay, u boundaries on this one means arctangent of infinity, we talked about that, was what? Pi over 2. Arctangent of 1 is pi over 4. So this means I'm going to do 1/2 pi over 2 squared minus 1/2 pi over 4 squared. Goodness, jumped like 4 steps ahead of myself on that previous one. Which means that no matter what this is, it's a constant, right? So it converges. Ignore my previous stupid statement. 2. All right.
How do you connect that? It's impossible. This doesn't make any sense.
All right, page 2. What do we need to look at on page 2? P series is rather straightforward, right? Anything page 2? All right, page 3. Gavin emailed in a request for 93 and 97. He did. He asked me to record the homework and specifically 93 and 97. I'm kind of impressed, actually.
That sounds so responsible. I don't think that was
Yeah,
bad.
see, this is why I used to call, and he can hear this now on the video because I'm still recording. I used to call Gavin a closet studier because he pretends he doesn't study, but he does actually study when he's at home.
I wonder if his mom stole a computer and emailed you for him.
I don't know. 93 and 97. All right.
This is 1%.
What do we got going on in 93? What is a good way to find 93?
Bo button ECC.
Oh, you could. Yeah, you could do the limit. I thought about it differently, but yeah.
That's what I did. Oh, there's some Japanese. Are you gonna hold it?
I'm thinking about it. I talked with your mom about it actually.
Based off of the limit thing here, what would this give me? 1? Yeah? Because that is 1, what does that test tell me?
Converges, right? No, it doesn't. I'm a liar.
Where did I leave?
It was in that would mean it's
Staff worker? Oh, thank you.
We got a hard at the teacher.
Yes. So the nth term test only goes for divergence, right? So this is if it's any constant, it diverges. What else could you have done on this one? I did the integral test using the denominator underneath the root as my u. Okay, so you could have also done the, where I'm really losing my names here, integral test. And that would have also given you diverges because it would have worked out to infinity. So, either way. What about 97?
It diverges, right?
Yeah, this one definitely, like, if you're going to look at just like a common sense one, this is going to diverge, right? It's positive, increasing, blah, 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 all of that work, okay? You can do all of the work on this one, too. If you had to show this, an integral test would work great for this one. If you do that, that's going to be the integral from 2 to infinity of 1 over x times ln of x cubed dx. What would be your u substitution for this one? ln x. So I would say u equals ln x du is 1 over x dx. Therefore, x du is equal to,
Your answer key also says converge.
does it?
Yes, and that's,
She said,
I mean, I don't know if that's right, but.
So hang on, let's see, maybe we're
I got
wrong.
divergence because I didn't solve it and I looked at it and said that looks divergent.
This, if I was going to do the common sense method,
Well, because
the bottom is smaller than n,
well, we had one that
so it
was-
should be converge. We did have one that was just an ln of n, but it's because it's cubed.
That's stupid.
That's more on the bottom, okay? So this one, if I kept going here and showed my actual work on this would be the integral 1 over x, I'm going to say 1 over x by itself times u to the negative third. And instead of my dx, I'm going to put in x du. My x's cancel. My boundaries will be ln of 2 and ln of infinity, right? Which you could just say is infinity, right? So this becomes u to the negative second with a negative 1/2 out front on the boundaries ln of 2 to infinity. Therefore, negative 1 over 2 infinity squared plus 1 over 2 ln of 2. This is going to go to what? 0. So I do get a constant back out. Okay? Because of that, we know it. Integral test tells me what? Converges. All right.
I like my way better because I did these.
Yes.